Introducing combinations 5.30. If we have n different objects, we can arrange the objects in different orders of selection without repeating the objects. Each different order arrangement is called combinations. So the key thing here is we didn't repeat any object. Note, the order of arrangement does matter in combinations because ABC is same as ACB, hence it's been repeated. Repeat of objects are not allowed if objects are arranged in different ways. So now how do we're going to compare permutations and combinations and how we write the formula. This is how we write permutation. N permutation R equals n factorial over n minus R open close bracket factorial. N combination R, if we times it by R factorial, we will get the same as n permutation R, which is n factorial over n minus R open and close bracket factorial. So n combination R, if we divide n combination R, if we divide both sides by R factorial, we would then get n combination R equals n factorial over n minus R open and close bracket factorial times R factorial. The R factorial is reducing or eliminating the repeating factors. And we can also write n combination R as n colon R open and close bracket. Combinations of the three letters A, B, C taken together are. To answer this question, I'm going to compare it with permutation and combinations. So I'm going to do the same question as if it was asked for permutation. Permutations of the three letters A, B, C taken together are. And then I'll compare that with combinations of the three letters A, B, C taken together are. Now I've written the general formula for the permutations and combinations. If we're doing permutations, it's going to be n factorial over n minus 1 open close bracket factorial. And if you're doing combinations, it's going to be n combination R equals n factorial over n minus R open close factorial, n minus R open close factorial times R factorial. In this case, n equals 3 and R also equals 3. So for permutation, that will be equals 3. So if I have 3 permutation 3, so that's what I'll get here. 3 permutation 3, 3 factorial over 3 minus 3, which will be 0 factorial. 0 factorial is 1. 3 factorial over 1 is what I get next, which equals 6, because 3 factorial equals 3 times 2 times 1, and that's 6. So for 3 combination 3, I get 3 factorial over 3 minus 3 factorial times 3 factorial. And so we got 3 over 3 minus 3 factorial over 0 factorial times 3 factorial. 3 factorial, we cancel 3 factorial. 0 factorial is 1, so the answer is going to be 1. So I can only get one combination because the rest will be repeated. So the combinations are here, 6 of them. ABC, ACB, BAC, BCA, CAB, CBA. You can see A, B, and C has been repeated 5 times. Well, 6 times altogether. That's why this is 6. So for the combination, we can only pick A, B, C without repeating them. That's why this is 1. Question B. Combination of 3 letters A, B, C taken at 2 at a time are. Again, I'm going to answer this question for permutation. So if there was a permutation here, and I'm doing it for combinations. So for 3 permutation, 2, that means you got 3 datas and you're picking 2 at a time. That is 3 factorial divided by 3 minus 2, that's 1 factorial, equals 3 factorial over 1. 1 factorial is 1. Therefore, 3 factorial is 3 times 2 times 1, which is 6. So you will get 6 permutations. So 3 combination 2 equals, sometimes we write it as 3 column 2. That's another way of writing this. NR, which equals 3 factorial over 3 minus 2, that's 1 factorial, times R factorial, which is 2 factorial. So it's that one. And then that equals, well, 2 factorial is 2 times 1, which is 2. 3 factorial is 6. 6 over 2 is 3. For the permutation, we just go 6, 4, is because for the 3 sets we've got, so we can take AB, that's AB, and we can take AC. Those are the first 2. With B, we can take BC, that's BC, and we can take BA, so that's BA. And for C, we can take CA, that's CA, and CB, and CB. That's why it's 6 permutations. For the combinations, we've only got A, B, C. So if I write it out here, A, B, C, and therefore we can take AB, 1 combination, AC, 2 combination, and CB, 3 combinations. We cannot repeat them.